All right, so I'm going to try to wrap up the idea of using object-oriented systems to design schemas by kind of going to the extreme, and that is to say, let's just get rid of the whole schema design part and work entirely in object-oriented systems. This is what's known as an object relational mapper. So we write some classes, and we work with those classes, and we let somebody else, namely the person who wrote the object relational mapper, to generate tables from those, automatically get data from tables to the Java classes or C# classes or whatever. And it's a fairly, I guess I want to say, seductive idea that we don't have to do any of the database stuff. We just write in our favorite object-oriented language, and somebody else does the dirty work. We'll talk later about the difficulties with that. But for now, I want to show you what is perhaps one of the best object relational systems out there, and it's called Hibernate. It was originally done for Java, but it's actually been translated to many other languages. Okay, so here is a Hibernate mapper. Like I said, basic approach, you design a whole bunch of Java classes, and then you tell Hibernate, hey, these are the classes that I want to be able to persist, and it deals with how to persisting them. So that still leaves open the question of, well, how exactly do we map tables to these classes? Okay, and Hibernate offers a couple of solutions. The first solution is based on XML configuration files. Oh my God, it is just god-awful. But essentially the idea is that there is some global configuration object. You can use that global configuration object to create what they call a session factory. And a session factory then, as a factory you would expect, it will create one or more sessions. And each session then is what you use to be able to get data. Okay. Thank God that Hibernate also offers an easier way, and this uses Java annotations. So Hibernate predates annotations in Java, but once annotations were added to Java, Hibernate came back and says, hey, this might make our life easier, so they adopted them. So here's how it looks like. They have a public class, faculty, okay, and we're going to add a whole bunch of stuff to faculty, but what we'll do is we'll mark it as something that we want to persist in the database, and that is as simple as adding the @entity annotation. Okay, so that's just an annotation for the class, and it will automatically get added to a table called faculty. Okay, that's just the same as the class name, as you can see. Okay, now inside this is just Java code. Okay, but we're going to add to this Java code some extra annotations for what's being persisted. Now here are the attributes we want. We want a faculty ID. So that's FID, and the faculty ID, we're making it a long, have to be something. Notice that that's a capital long as opposed to a lowercase long. What that means is that this is the version of long in Java that can actually have a null value, because it's actually a pointer to an object as opposed to a 64-bit integer. So since it is a pointer, it can actually be null in Java, and we like that when we're dealing with mapping classes to databases, because databases can have nulls for anything. So if you define a lowercase long field here, and for whatever reason that is null in the database, then you will get a runtime exception when you try to load that record from the database. So just out of habit, I always use the uppercase versions of the numbers. Now here we created the field called FID. Again, this is just general Java practice. We create the getter and the setter for that field. And right here, we can add some more annotations. We add the annotation @ID. That tells Hibernate that this is the primary key. Okay. By the way, Hibernate really, really likes it when you have only one attribute as the primary key. So I usually just create a synthetic primary key anyway, so that works well for me. Okay. The other item of interest here is this @generated_value. And what that means is that we're asking Hibernate to go ahead and come up with its own keys if you don't specify them. So if you create a faculty member, you add the first name, the last name, whatever else you want to add for the faculty. Since it's a synthetic key, then you're not actually going to set the faculty ID, right? Because there's no reason to set it to one thing over another. You're asking Hibernate to do that for you, and it'll likely do a better job than than we would anyway. Okay. Now let's go ahead and add a few other things. We're adding a field called fname, which is faculty name, and you have the getters and setters because it's just Java code, and there are no annotations on it whatsoever, right? There's no at something. So Hibernate will simply look at it and go, oh, that's just an attribute, so I'll add it to the table faculty. The table faculty will have an attribute called fname, which is a string, by the way. All right, so here is specialty. It's just like fname. It's just a string that has a getter and setter. So again, Hibernate will map that to specialty. And then we have something very strange, which I will talk to you about later in more detail. But we're going to assume that every faculty member has a whole bunch of advicees. Okay, so it would be nice for a faculty member to be able to say, I want to see all my advicees. And remember, that is a question of navigability. Can I get from the faculty object to the advicees? And we're going to say that, yes, we want to be able to do that. So what we'll do is we'll create a set of students. Okay, this could have been an array, it could have been a list. It needs to be some collection. But we'll create a collection of a set of students. And that is simply a hash set. This is Java, right? We're just initializing it to an empty set. But then we have this magical thing here, okay? And what this says is that the advicees are actually mapped by the field called advisor in a one-to-many relationship, okay? So there's two kind of important components here. The first one is the one-to-many part, and what that says is that each advisee has only one advisor, right? Which is a reflection of real life here at UW anyway, the way we do advising. Okay, that means that if that line between those two tables, or classes, if we're talking UML, we'll have we're not going to turn into a table in its own right. Instead, we're going to have the student point to the faculty member, right? That's what we talked about when there was a 0 to 1 or 1 to 1 end on the other side. So yeah, because of that, then there's not an extra table. Instead, the advisor attribute, and that's where map by comes in. It is called the advisor attribute of the table student, because that's the table that I'm associated with, then will point back to me. And that's how you know that that is one of my advicees. So notice that we're actually telling Hibernate quite a bit, because we built this using what we want in Java. In Java, I want to be able to get from the faculty member to the advicees. And then we're also giving it enough hints that it can figure out, using kind of the standard ways of creating tables, how it should fill in this particular record. Okay, so let's look at students. And in students, again, we classify it as an entity, but we're also going to say, oh, I'm going to give you some extra information about the table. The name should be students, and it's plural because we said earlier that, tables should be plural. So the Hibernate default would fail here because it would just be student. We can override that. All right, so here we have a key, just like before, right? There's nothing new. We have student name, again, nothing new. We have GPA, okay? There's essentially nothing new here other than this is a float. And again, notice that we use the uppercase float just in case it's null, although I guess a student with a null GPA would be a little weird. But anyway, we come to the big point. We have a private field called advisor of type faculty. Notice that that is just the type of one of the classes that we have, right? And what we're saying is that this is the other endpoint of an association. If you remember, the way that we had this association worked was one-to-many in faculty. And that's because one is the faculty end, okay, is the first end, and is the one in this table, in this class. So from one faculty, we get to many students, and that's why this is a set. But over here on the student side, it is many to one, because from many students, you can get to the same faculty member, okay? So notice that the directionality of those annotations in Hibernate, and excuse me. So that's the way those terms are used. The first one, many or one, has to do with the table that we're in, the class that we're in. So this is many students to one faculty. Now, the rest of this is just plain Java. I mean, the way that I would do this in Java is to have a faculty advisor and getters and setters for it. That's it. I'm done in the Java world, right? It's a little more interesting in the relational world, so that's why we have to give these annotations. What's nice is that once you do that, everything else is taken care of. Okay, so let's actually use those. Here's a faculty member F. I don't care how we got this faculty member, and we'll hop in a for loop. For each advisee in f.getAdvisees. F.getAdvisees is a set, and then we're simply using the Java notation to iterate over all elements of a set. Inside of that, we have an advisee, and we can do anything we want. In this case, we're going to send a reminder to them that next week is advising week, and really they should show up. So that's the kind of thing that we could do. That's on the faculty side. Now look at this. This is actually kind of cool. I have a faculty and a student, and I go over to the student and I say, hey, your advisor should be this faculty member, and then I save the record. Okay. In fact, I'm going to commit that. Once I do that, then if I look at the faculty side and I do a get advisees, that student S will show up. So even though I never explicitly added it to that set, okay, just by virtue of setting the advisor of the student to be the faculty member, then that student will get automatically added to the set of advisees in faculty. You can also do it the other way around. I could go to that set and add an element, and then that would actually set the advisor. It's just me probably, but I find that a little crazy. So I always do it this way, where I set the faculty to the advisor. The other way makes me nervous. I can't explain why. I just worry that it's not going to do the right thing, even though it does. Okay, so let's wrap up by talking about subclasses and how Hibernate should handle those. And Hibernate actually supports all three methods for doing subclasses. So it has its own terminology for those. It calls it a table per subclass, a table per concrete class, and a table per hierarchy. Okay, so we'll do that, and to illustrate, we'll create a new table called person, and we'll have student and faculty, both of them inherit from person. So we'll start with the table per subclass. So to do this, we'll say we add the annotation inheritance, and we say strategy is joined on the parent class, only on the parent class. Okay. Now, you also have to say, well, okay, so we're joining, so what is the ID that all the things join in? And you do that by specifying the primary key join column, okay? And you do that on the subclasses, all right? So let's take a look. Here is the person class. So it's an entity. We're going to default. We'll let it get called person. And here is the inheritance, and strategy is joined, okay? So person has an ID, which is of generate value. It's got a name. Those are the only two things in common. So those are the two things that we have abstracted to person. Okay. So let's look at faculty. This is a Java class. Faculty extends person. So there's the subclassing. And of course, it's an entity. All right, because we want to generate a table for it. And here we're going to say that the primary key join column is ID. Okay. Now, if you look at the actual fields of faculty, you'll notice that it doesn't have an ID, and that's because it's inheriting it from the parent class. Okay, so actually the only thing that's here is specialty, because those are the local attributes of faculty. Okay, so looking at student is exactly the same. Primary key join column is ID. We don't have to put get ID or any of that because that's inherited from the parent class. We do need GPA, so we add that, and it gets handled just fine. Okay, different approach, one per concrete class. So this is the one where we kind of figure out all the possible endpoints and then make a table for each one of those. Okay, and the way that we'll do that is we'll add the inheritance annotation to the parent class, and we'll say that the inheritance type should be table per class. And if you want to specify the column names on the subtables, then you simply use attribute overrides. And let's take a look at that. So here is the person class. This looks exactly as before, except the inheritance has changed to be table per class instead of joined. Other than that, is the exact same Java class. Here is the faculty class. So now we're not going to tell it what the primary join key is, because there is no such thing, right? We're not joining them. Instead, what we have to say is, oh, look, there is an ID field in my parent, and what I really want to call it is, well, actually I kept the same name, so I didn't really need to override it, but this just tells you how you could overwrite things. So the names in the superclass can actually get changed in the concrete class. This doesn't make sense when you're doing things by joint, because you don't copy all the attributes down to the subclass. It only makes sense when you're copying the attributes down if you wish, for whatever reason, although I suspect it would be a bad reason, to rename them. Okay, so here we are. This table will have ID, name, and specialty. And here's the same thing. We'll have ID, name, and GPA for the students table. Okay, now let's try to do the mammoth table that just handles everything. So that is what Hibernate calls a table per hierarchy, and sorry, I was expecting this to say table per hierarchy. Actually, it's just single table. That's the kind of thing that I always just look up when I'm coding. But the inheritance type is called single table in the style, and we need a discriminator column. And what a discriminator column is actually the type column that I told you that I always created, just so that I would know what kind of subclass this object really belonged to. Okay, so we're going to build a column called type. You can call it whatever you like. That's why we have the annotation that says which is the discriminator column. And then we have a discriminator value. And what we do is in the superclass, we say what the discriminator column is. That column, of course, will be shared by all the subclasses. And then in each subclass, we give the value that that column will take. So for instance, here is person class, and the inheritance strategy is single table. The discriminator column is going to be type, that's the name, and the type, the Java type of that column is going to be a string. It could also be a number, for example, which is fairly common. Even a short, you don't need that many numbers, okay, or a character, but I'm just going to go full-blown and make it a string. So because you can create persons that are not faculty or students, okay, then it is actually possible to instantiate the persons class, and I will give a value which I'm calling person. That's what type will have. So the type column of the person table will say person, okay. Now here we have, if you look at the types, we're going to have the ID, the name, and let's look at the next one. This is faculty, okay, extends person, and the discriminator value is faculty, okay. Now think about this for a second, because faculty has an extra attribute, specialty, right? But we're not going to build a table called faculty. Instead, we're going to just add that attribute specialty to our mammoth person table. And when we do, okay, the record that has a specialty, because it's a faculty record, in the type column, we will set the value faculty. That's how I can tell them apart. You can now imagine how it works for student. We'll simply add our discriminator value. So the type column will say student, and the GPA attribute will be part of person as well. Okay, so here are some takeaways that I want you to have. The first thing I want you to know is that Hibernate makes it really easy for programmers to model database schemas. This is a good thing, okay? Annotations map all concepts into tables. So even though I'm only going to build one gigantic table, I let you build a nice Java class hierarchy. Okay, that's beautiful. The trap, if you will, is to use Hibernate without actually knowing what you're doing, and that's impossible to do well. Okay, you're gonna have some difficulties further on. So you have to understand what's really going on, and then what's nice is you don't have to be the one who's doing it all the time. Okay. The other thing I want to tell you is that this is really only good for a first cut at the database schema. Okay, there are a lot of things that you need to do to a schema to make it, number one, beautiful, but number two, useful. Okay, so the beauty part of it is something we're going to talk about starting this week, really, and it's about how to make it normalized and how to make it have some really good technical properties. Okay, now the useful part has to do with how to make it fast enough, okay, so that you can actually solve problems with it. So it is simply impractical to build a database schema that does not have indexes. Okay, that's not going to be fast enough, I guarantee it. However, the folks who designed Hibernate actually deliberately left out indexes from their annotations. And the reason they did is because they don't want the schema that they generate to be the one that actually makes it out to production, if you will. What they want is for a human being someone who's very skilled at database schemas, and in their minds, that's the database administrator, to actually go in there and build a schema that corresponds to the Java classes, and then Hibernate will actually use that schema when it comes up. For instance, a string. Well, what should the string be? Well, maybe that should be a varchar. How many characters? Oh shoot, let's just default to 1,000. Okay, well, that's going to be a little big for regular things like names. So, you really want somebody to go in there and adapt those types of things. Okay, so actually, Hibernate, the advice they give you is do not rely on the automatic generation of schemas. If you do, you're a fool. However, go ahead and rely on that in your development system so that when you're developing, you can just develop quickly. And then when you migrate to production, then you actually have a team that can do this and think deeply about it and come up with better choices. Okay. Anyway, so like I said, we're now going to move our attention to designing databases, really good database schemas by hand. I want you to rely on your programming skills so that you can come up with the data structures and then create your first design of tables that way. Okay, and that will help you avoid that fear of the blank page. I don't know what to do, so I'm not going to do anything. If you don't know what to do, then start by designing some classes, which you have a lot of experience with, and then we'll translate those to tables. Once you get them into tables, then we'll start doing the stuff that we're going to be learning about in the next couple of weeks to translate that into a really good set of tables, not just a good set of tables. All right, I'll see you back on Wednesday. Go Broncos!